Hello, and thank you for joining us. Today's webinar topic is Operational Theory and Software Basics for Teledyne Leeman Labs Hydra IIC CVA Mercury Analyzers. Our presenter is Sarah Kennedy, Applications Chemist for Teledyne Leeman Labs. If you have any questions, please feel free to submit them throughout the presentation or email Sarah directly, and she will follow up with you after the webinar. This webinar is being recorded and will be available within a few days. Now I'm going to turn it over to our presenter, Sarah Kennedy.
Thank you for that introduction. I am Sarah Kennedy. I'm the Applications Chemist for Mercury Products here at Teledyne Leeman Labs. And today we're going to highlight our Hydra IIC Mercury Analyzer. So we'll go over a brief history of Teledyne Leeman Labs. Then we'll go over the benefits of direct mercury analysis compared to other wet chemistry techniques. And once we've reviewed the theory of operations, we'll go into an overview of the software, including calibration curves, setting up sequences, and some data analysis. Also, if we have any questions, be sure to submit those as we go along, and I'll be able to answer those by email. So this kind of shows where we've been and who we are. So Teledyne Leeman Labs has been going strong for more than 30 years. Leeman Labs was the first to offer a turnkey mercury analyzer in the early 90s. In 2004, Teledyne acquired Leeman Labs. And in 2007, the Hydra IIC, which is the topic of today's presentation, was released to market. This is kind of a family portrait of the products we offer here at Teledyne Leeman Labs. So first, we have our Hydra IIA, which is our introductory unit. Its principal analytical technique is chemical reduction of aqueous samples, followed by cold vapor atomic absorption. Then the next step up, we have our quick trace M7600, which follows the same principles, but has a lower detection limit and can measure into the nanogram per liter range. Then we have our quick trace M8000, which detects mercury in aqueous samples by chemical reduction, but it has the option to run with or without gold trap pre-concentration of mercury, and it's followed by cold vapor atomic fluorescence. Then, in kind of a league of its own, we have our Hydra IIC. So it operates by thermal decomposition, followed by gold trap amalgamation and atomic absorption. So we'll talk about that more. So our product lines were designed to meet US and European standard methodologies. They cover a variety of techniques and a variety of digest matrices. Our customers are all around the world in a variety of fields, mostly environmental, but also in academics, petrochemical, food, mining, agro, energy, pharmaceutical, nutraceutical, waters, and wastewaters. Here are some of the key features of the Hydra IIC. We have determination of mercury at trace levels for solids and semi-solid samples. We also have determination of mercury at low microgram per liter levels for aqueous samples. There's no time-consuming and complex sample digestion steps, which I think is the biggest advantage of using this instrument. So there's no wet chemistry pretreatment steps for solids and semi-solids. And since there's no wet chemistry, it also eliminates toxic waste generation. So that'll help your lab reach your green chemistry goals. And also, it frees up your analysts' time so that they can be more productive. So another benefit of using thermal decomposition is that our analysis is matrix independent. We have a mass-based analysis. So you can run one calibration curve for most samples, use standard operating conditions for most samples, and run them automatically without an operator intervention. And this allows you to have accurate data regardless of the different sample matrices. It also has a fast analysis time. So for solid samples, from sample in to data out is about 5 minutes. Here are the 3 most common methodologies for the Hydra IIC. We have US EPA 7473, which detects mercury in solids and solutions. ASTM D6722, which is total mercury in coal and coal combustion residues, and ASTM D7623, which is total mercury in crude oil. These are the three big ones. So let's dive into the theory of operation. So how does the Hydra IIC work? So it's 7 simple steps. We have the load and inject, then we dry and combust, purify, remove moisture, collect, elute, and detect. So again, this unit works by thermal decomposition. So we heat the sample until it decomposes. So there's no sample pretreatment needed. There's no reductant needed to convert the mercury species into its elemental form that happens during the combustion. So we have no expensive stannous chloride reagent needed, no sodium borohydride, anything like that. Our incident light source is at 253.652 nanometers, and we have a wide working range. Typically, it's from 0.05 to 1500 nanograms. So let's go through one step at a time. So first, a weighed sample is introduced into the decomposition furnace. So this is typically done by an automated sequence. You can do individual manual samples as well. And once the injector is closed, oxygen will flow over the sample itself. Then the furnace temperature is raised in 2 stages, first to dry the sample, then to combust or decompose the sample. The gases resulting from the decomposition are carried through the catalyst furnace, which removes halogens, nitrogen oxides, sulfur oxides, known interferences. Then the remaining combustion products, including that elemental mercury, are swept through the Nafion dryer to remove any excess moisture, then onto the gold trap that captures the mercury, but it lets all the other gases pass through. The gold trap is heated, which releases all the elemental mercury into the carrier gas, which transports it to the spectrometer. In the spectrometer, the carrier gas containing all that elemental mercury is directed through 2 5-inch high-sensitivity optical cells, which detects at low concentration, and then a 1-inch low-sensitivity optical cell, which is better for high concentration. So the light from the mercury lamp travels through the cells and uses a system of mirrors to go through all 3 of the optical cells. And then the signal is measured by the AA detector. And the 2 peaks are both integrated and reported against, and the system chooses the best calibration from the 2 cells available. So here's an example. So here, the green peak shows the integration for the high sensitivity cell, and the purple shows the peak for the low sensitivity cell. So the use of 2 cells provides a better detection limit and a wider dynamic range than if you just had a single set optical path. So here's an overview again of some of the benefits of direct mercury analysis. So this unit is capable of determining mercury levels at trace levels for solids and semi-solid samples, and the low nanogram per gram level for petroleum and petroleum distillates, and in the low microgram per liter, so part per billion level for limited aqueous samples. So you can run a limited high sample size of about half of 1 milliliter for aqueous samples, but it's really designed for solids analysis. So that's about the largest sample size that we would recommend. And again, there's no time-consuming and complex sample digestion steps. It's simple. So as I just mentioned, it's really designed for solid samples. It's not recommended for trace level determinations in water. If you need to run trace levels for water samples, there are other great options from Teledyne Leeman labs that were designed specifically for this, but I wouldn't recommend the Hydra IIC for a sample load that's mainly aqueous. So another huge benefit of using thermal decomposition is that the detection limits are superior to liquid digest. So a typical detection limit is 0.001 nanograms. So if you run the numbers on that, and you divide the mass detection limit by the sample weight introduced, you'll get the concentration for the detection limit. So for this first example, if we take 0.001, which is our detection limit, divided by 0.2 grams of a sample, which is a typical injection size, then our detection limit is 0.005 nanograms per gram. And below is an example of a slightly higher weight, a 0.5 gram sample. It gives you a detection limit around 2 parts per trillion. If you took those same sample weights and did a wet digestion and brought them up to a 50 milliliter final volume, your detection limit would be 10 times higher. They'd be at 5, 50, and 20 parts per trillion. So thermal decomposition allows you to have a superior detection limit than running the same sample on a wet digest. There are a number of applications and technical documents that show that really showcase what the Hydra IIC is capable of. So we can say yes to aqueous analysis by US EPA 7473 if we take advantage of our advanced moisture control system. So we use an external dryer, which uses magnesium perchlorate to remove some excess moisture and allows us to run aqueous analysis. You can also say yes to volatile hydrocarbon samples, yes to air analysis, yes to thermal desorption speciation, and also yes to methylmercury by selective extraction. So how does the Hydra IIC improve productivity? It has a very fast analysis time. So it's dependent on the moisture of your samples. The dry samples only take about 5 minutes each. Aqueous samples take 8.5, but again, 3.5 of that will be drying time for aqueous samples. It has a high sample capacity, so you can run 70 samples unattended, but if you have an analyst present to exchange the racks once they are used, you can run virtually an unlimited amount. You just have to keep adding them in the sequence, and I'll show you how to do that later in the presentation. So 60 samples takes about 5 hours. How does that compare to a reduction-based system? For them, 60 samples takes 5 or 6 hours with the digestion. It's method dependent, of course. Your timing will change depending on what method you use. But we're faster after 60 samples if you exclude all those digestion steps, the time, the labor associated with those. So when is thermal decomposition most useful? For the analysis of solids, such as soil and sediment sludges, coal and fly ash, or fish, foods and feeds, plants and tissues, and other biologicals. It's also really useful for difficult to digest samples. I recently was trying to run a sample and it just did not want to do a wet digest. It would form this weird lumpy substance. It just did not make a homogeneous sample to digest. So I sequenced it on the Hydra C, and I had my results in an afternoon, wrote up the tech note that same day. So it's very fast and a big advantage if you have a difficult to digest sample. It's also useful with samples with known chemical interferences when using reduction techniques. Here's 2 examples of that. So as you can see in this first graph, the percent recovery of mercury goes down to 0 when you get to about 2.5% of potassium iodide in the sample. But by thermal decomposition, it's basically unchanged. It remains above 100%. You see a similar trend with gold. By about 250 ppm of gold in the solution, the percent recovery drops to 0. But by thermal decomposition, it remains basically unchanged. So here's a great example of a calibration made with solid CRMs instead of aqueous standard. So we have our matrix independent analysis on the system because it is mass-based. So we can run one calibration curve with our standard operating conditions, and we can run multiple sample types automatically without operator intervention. You can see here we use oyster tissue, coal, dogfish, and sediment all to create our calibration curve, and it still had a strong correlation using multiple matrices. So now that we've gone over the principles of operation, let's move on to an overview of the Envoy software. So it's intuitive and it's navigation friendly. It has three main tabs: method, sequence, and analysis, which are found here on the bottom. And then the view, run, and tools remain the same. So let's begin with the method tab. So when you click method at the bottom, you have, it changes this here at the top. And your options are new, open, rename, save, and clone. So you can create a totally new method, open one that you've already made previously. You also have the option to clone a method, which I think this is very helpful. You can make a template and simply clone it. You can rename it, change your analysis, add any notes, and you're ready to go. So for the instrument control tab, that's your first option here. It kind of is a walkthrough through the flow path of the unit. So first we have our auto sampler control here and our injector control, our gas flow. So both of those go into the furnace where you can set your drying and decomposition temperature and timing. Then it goes to the catalyst region where you can change your temperature and timing, through the Nafion dryer to the blow trap or the amalgamator where you can edit your temperature and time. Then the sample flows through the optics where the lamp also shines through to the detector. You have all that control here from the instrument control panel. And then once you have your method set up, how you'd like it, you can run your calibration. So we recommend calibrating with aqueous standards created from a serial dilution. So that chart is shown here at the bottom. We start with the stock standard and do serial dilution to get our intermediate standard. We also recommend starting with these basic operating conditions that's shown at the top right. And I cannot stress enough how important good laboratory practices are when making this calibration. You should wear gloves when you're handling the standards and the boats themselves. A non-detect on a flow-through system is going to be additive because this is an amalgamation system, so every little bit adds up. So we prepare our calibration standards from our intermediate standards on the previous slide. We run 7 standards and a blank for each range. So we have a low concentration range and a high concentration range. And then it's mass-based, so we just vary the weight and the volume of their intermediate standards to meet the mass requirements. So for example, our 0.1 nanogram or 0.5 nanogram are made from the same intermediate standard, but we vary the weight. So we add 100 microliters to get 0.1 and 500 microliters to get our 0.5 nanograms. We also need to vary the dry time depending on the sample weight. We recommend about 70 seconds per 100 microliters of solution added into the boat. And you can edit that when you make your sequence. So we'll get there shortly. So here's an example of our low range calibration. So typically we go up to 20 or 30 nanograms in the low range. Here's an example of a linear fit. You can also run quadratic or weighted fit. If you click in the chart down here, you can click and choose different points. You can include them, exclude them, you can delete them. You can also have multiple points of the same mass, and the software is not going to give you any grief for that. So my preferred approach for this is to include the 50 nanogram point and then use a quadratic fit. So it really helps dial in those in-between values, the 1, the 5, the 10. It gets them closer to their true value. So I would highly recommend adding in the 50 and using a quadratic on the low range. For the high range, typically we go up to 1,000 or 1,500 nanograms. We always want to run a quadratic fit in the high range. And again, you can pick and choose your calibration points by selecting them in the table. You can include them, exclude them. You can also delete them. And you can run multiple points at the same mass. So my trick for the high range calibration is to include the blank. You still run your quadratic fit, and again, it just really helps dial in those in-between values and get you a better calibration curve. So once you run your calibration, you'll have to accept the points or just hit the accept all button, and it will give you your data for your curve as well as your correlation coefficient. If you add or delete any points, you'll have to go back in and accept them, and it will update your calibration data. You also have an option to clear the calibration completely and start over. You can delete individual standards, and you can print the calibration graph. So now we're moving on to the sequence tab. So you'll have the option to create a new sequence, open a sequence you've already created, save, print, and exit. So you have the options at the top to help you create your sequence. You can cut, copy, and paste. You can auto number down. You can fill down. You also have inner control, writer down. It's kind of a little customization feature. So you can decide if when you click enter on your keyboard, if it goes down the column or across the row. It's really just up to your analyst preference. You also have the option to right click and select start from here anywhere in the sequence. So for some reason, if you had to interrupt your sequence, you didn't have to start at the beginning of the whole sequence. You don't even have to start at the beginning of the rack. You can start right where you left off. You just have to reset the rack you want to start from into the starting position. That's the only trick there. All right, so let's focus for a minute here on our sequence parameters. So our first column is our sample type. So you can select calibration standard, unknown, you can run QC standards, and you also have the option to preload. You can customize each sample's temperature profile. You can also change the sample's time at that temperature. So this is where we would vary our drying time based on our sample weight. You can individualize it for each sample. And a lot of them have little drop-down menus, so you can just select the top box, and it will have the values you can select preloaded. So a really cool feature we have is that preload sample type. It allows you to do multiple injections of the same sample and load them all onto the gold trap, and you can elute them all at once. So if you select preload for the example here, it's the first 6 samples. Then on your 7th, you select unknown as your sample type. It will run all of the samples, and then it will elute on that final sample. It won't burn the gold trap until that unknown is ran. Then the software will take the response and divide it by the summed weight of your total preload, and it will give you a concentration based on that. That's a pretty cool feature. All right, so now we're moving on to our last tab, which is the analysis tab. So here we have the option at the top to view the results, view the control charts, the report, and you can recalculate data. And then toward the middle, you can show the raw data. You can create a CSV file by highlighting samples. It's the raw data export. You can also print the graph for each sample at the bottom of the screen. So let's start with the Show Data tab. So this goes through and will show you the data point number, the time in which it was collected, which time is the x-axis in our chart and our graph of the peak there. It will show you the raw intensity, which is based on your lamp signal. You will see the scan microabsorbance, the baseline and the peak microabsorbance, the background data, and then your peak absorbance, which is your readout for microabsorbance. And you also see your corrected peak values. So I mentioned earlier that the software integrates and reports against the best calibration range. So this shows you the value for each of those ranges. So at the top, in the low sensitivity region, you're at 125,000. So that would be in the low calibration curve. That's where it would report. I believe it flips over to the high range of a little below 400,000, about 380,000. So for the other options at the top of the screen, we have our control chart, which lets you see some different variables side by side. More importantly is your reports tab. You're going to be using this one a lot. So you have the option to change 29 different fields. We also have the default option, which is what's shown on the screen. You can add and subtract whatever you need for your LIMS system. You can just click on the report button. You can print right from here, and you can export as a CSV or Excel file. And the last tab is recalculate. So you can use this if you accidentally typed in the wrong weight for a sample. You meant to type in 0.1, you typed in 1.0, and now all your math is wrong. So if you just click on the sample in the tree on the left-hand side, you can change the weight and hit the recalculate button. It'll do the math for you. It adds a new line in the tree. It also changes the little boat icon. So just for traceability reasons, you know that it was recalculated. So also in the analysis tab, if you click on the chapter of the analysis, you have the option to exclude single points or all points from the report. You can also rename samples from here. Again, if you accidentally type in the wrong one, you can select it and rename it. It also has a name history for traceability. So those were the three main tabs, but the four other options remain the same no matter what tab you're in, which is View, Run, Tools, and Help. So from View, you can see all chapters. You can just see the latest chapter, or you can select a date range. And Run gives you the option to run a standard, a QC check, a sample, run an entire sequence. If you have a sequence running, you can interrupt and run an urgent stat sample. You can also stop the sequence or break the sequence. And then next we have Tools and Help. So under Tools, you can change the user or set up user accounts. So this would be more for like a laboratory manager. It works kind of like the admin on a computer. You can set different responsibilities for different users. Then we have Database Manager, Event Log, and Audit Trail. So this is for those traceabilities that we were just speaking about. Then we have our scheduled maintenance, sample conveyor, instrument diagnostics, your standard libraries, your check standard libraries, your chart recorder, which is kind of a live view of some different parameters, and your sample search. And in the help file, you have Envoy Help is a searchable pop-up window that lets you ask questions and find out more about the Envoy software itself if you're trying to find something specific. You can also see the different startup file commands. It's kind of a culmination of all of those in one single spot. And then about Envoy, which gives you your software and firmware version. And also at the top of the screen, you have your favorites bar. So this is where we put all your day-to-day activities, your most used icons. So you have your run standard, run check standard, run sample, sequence, username, all those types of things. We also have different buttons that control your instrument status. So you have the stop button, the startup button, standby, and then sleep. And sleep is a good function because once your sequence is over in the software, you can select for your unit to go to sleep. It'll change, it'll monitor your catalyst and combustion zone temperatures. And so it'll close the injector, and then the fans and the gas will turn off once it gets to that temperature. So it puts itself to sleep at the end of the night. You don't need an analyst to turn the instrument off. So also on the favorites bar, we have the maintenance button. So this will light up red when a task needs to be completed, and it offers you step-by-step instructions on how to perform that maintenance. So the bottom screenshot on the right is from my desktop computer, so I don't have a system hooked up to it, so all of my maintenance is timed out. That's why everything is in red down there. So I double-clicked on Replace Front O-rings, and it brings up the step-by-step instructions on how to perform the maintenance. So that's really handy. It makes things really easy. And then next we have our key component changes. So a catalyst tube lasts about 500 samples, gold trap about 1,000. and our Nafion dryer about 5,000 samples. So our furnace and autosampler module is on one base that slides in and out for easy access to the manifold at the top of the furnace. And again, for maintenance, we have easy access. So our detector module cover flips up and over the top, so you have access to the entire optical assembly in the front. As I mentioned before, the auto sampler and the furnace are on that base plate that slides in and out, so you can easily reach your Nafion dryer and your gold trap, which is inside your manifold. And then our injector has one retaining thumb screw on the front, and if you release that, it will slide off to the left, and releasing two more thumb screws on your interface will get you to your catalyst tube. So it only takes about 1 minute to exchange a catalyst tube. It's very simple. So let's dive into some actual data. So we ran this as a validation for all three of our applicable methods. So let's start with US EPA 7473 for solids in solution. So the first table shows our operating conditions, and then below it shows our check standards for 7473. You have to run a low level curve check and a high range curve check. So we ran a solid SRM 1633C, and you can see we have 103% recovery, which is very good. And then our 7 replicates of our sample was SRM 1619B, which is the solution, it's fuel oil, and we got 3.94 plus or minus 0.018 nanograms per gram, which is well within the certified value of that solution. So that validates US EPA 7473. Next up, we have ASTM-D 6722, which is for coals and coal combustion residues. So our solid sample is SRM 1633C, which is coal fly ash. So we had 103% recovery on that. And last, we have ASTM-D 7623, which was for crude oil. So our 7 replicates were for crude oil, 1619B. And again, we had 3.94 nanograms per gram, which is well within the certified value. So the takeaway from that is you can use one sequence using standard parameters, but use different sample matrices, and you can validate all 3 of the major methods. And this would only take about an hour to do. That's pretty impressive. All right, so to summarize, so the Hydra IIC is applicable to most direct combustion methods. It has a superior detection limit for solids and semi-solids compared to wet chemistry techniques. It's easily maintained, and it will give you years of trouble-free operation. So thank you so much for listening. If you have any questions, feel free to email me, or my office phone number is listed there in green. You can also follow us, like and share. We're on all social medias. So thank you so much for listening today. I hope you gained a little more insight into the Hydra IIC mercury analyzer.